section, let's see the verification of reciprocity theorem in AC circuit. Let's consider a simple example for that one. In the circuit shown below, determine Vx, that is the voltage across the capacitive reactance minus J2, by applying reciprocity theorem, and we need to compare the voltages in both cases. So in order to apply reciprocity theorem, let's consider two branches AA dash, first branch, BB dash, second branch. In AA dash, we can have an independent current source having value 20 angle 90 ampere. In branch B, we can have the response, that is the voltage across the branch BB dash is Vx. So in first case, due to this excitation, we need to find out Vx, that is voltage across B dash. So in order to find out that one, first of all, we need to find current flowing through this branch, that is current flowing through Z2. Here Z1 is having a value 10 plus J5 and Z2 is having a value J5 minus J2, that is J3. So in order to find out I dash, we can apply current division rule. So I dash is equal to main current into other branch impedance divided by net impedance. Here, when we are considering the net impedance in two parallel branches, the net impedance is coming as 10 plus J8. So substituting I, Z1 and Z2 in this equation, we can obtain I dash as 17.46 angle 77.91 ampere. Now we can easily find out Vx. What is Vx? I dash into this impedance alone, that is minus J2. So substituting the value of I dash in this equation, we can obtain voltage across BB dash, that is Vx, as 34.92 angle minus 12.09 volt. In second case, we need to remove this independent current source having value 20 angle 90 from branch A, and we need to connect that independent current source across branch BB dash. So due to the application of this current in branch B, we need to determine the voltage across branch A. If that voltage, due to the application of current source in branch B, become equal to Vx, in this case, we can say that this network is satisfying reciprocity theorem, or we can verify reciprocity theorem in that manner. In next case, we need to remove the current source 20 angle 90 from branch A, and we need to connect that into branch B. Due to this current source, we need to find out the voltage across branch A. So in order to find out VA, that is voltage across branch A, first of all we need to find out I double dash. So during this condition, this is the main current, and this combination, that is J5 10 plus J5, this is in series. That combination is in parallel with minus J2. So I double dash is equal to main current I into other branch impedance, that is minus J2, divided by total impedance. Total impedance is coming as 10 plus J8. Substituting these values, we can obtain I double dash is equal to 3.125 angle minus 38.6 ampere. Now what is VA? Voltage across branch A. It is nothing but voltage drop across Z1. That is I double dash into Z1 gives VA. Substituting the value of I double dash and Z1 in this equation, we can obtain VA as 34.92 angle minus 12.09 volt. As VA is equal to Vx, the circuit satisfies reciprocity theorem. That is, reciprocity theorem is verified in the circuit. Next problem is verify reciprocity theorem in AC circuit shown below. Here we need to take the current through Z3 as response. Here, in order to apply reciprocity theorem, let's consider two branches A dash, that is branch A, and branch B with terminals B dash. In branch A, we can have an independent voltage source with a value 50 angle 90. In branch B, we can have an impedance with value 2 minus j2 ohm. Here, current through branch B can be considered as I dash. Here, excitation is applied in branch A and response is the current flowing through branch B. In order to find out I dash, first of all, we need to find out the main current which is supplied by the source 50 angle 90 volt. So as we know, I is equal to voltage divided by net impedance. The equivalent impedance of the circuit Z equivalent is equal to Z1, which is in series with this parallel combination Z2 and Z3. That is Z1 plus Z2 parallel with Z3. Substituting the value of Z1, Z2 and Z3 as 2 ohm, 3 plus J4 ohm and 2 minus J2 ohm respectively in this equation, we can obtain Z equivalent as 4.59 angle minus 7.76 ohm. Substituting the value of Z equivalent in this expression, we can obtain the current supplied by this voltage source as 10.88 angle 97.76 ampere. Now we can easily determine I dash by applying current division rule. So I dash is equal to main current into other branch impedance Z2 divided by total impedance in parallel circuit, that is Z2 plus Z3. Substituting the value of I, Z2 and Z3 in this equation, we can obtain I dash, that is the current flowing through branch B, that is our response, as 10.10 angle 129.09 ampere. In next case, we need to remove this voltage source from branch A and we need to connect this one in branch B. So by applying this voltage source in branch B, in next case we need to find the current flowing through branch A. If that current through branch A, due to application of this voltage source in branch B, become equal to I dash in this case, we can say that the circuit is satisfying reciprocity theorem. In first case, we got response as I dash is equal to 10.10 angle 129.09 ampere. In next case, we removed the voltage source from here and connected here. Due to the application of this voltage source in branch B, we need to find out I double dash. In order to find out I double dash, again we need to find out Z equivalent. In this case, Z equivalent is equal to this impedance, that is Z3, is in series with the parallel combination Z1 and Z2. That is Z3 plus Z1 and Z2 are in parallel. Substituting the value of Z1, Z2 and Z3 in this equation, we can obtain Z equivalent as 3.86 angle minus 24.62 ohm. Then we can find out the current as voltage divided by Z equivalent. Substituting the value of voltage as 50 angle 90 and Z equivalent as this one, we can obtain current supplied by the source I as 12.94 angle 114.62 ampere.
Now we can find out I double dash
by applying current division rule, that is main current I into other branch impedance Z2 divided by total impedance in this parallel circuit, that is Z1 plus Z2. Substituting the value of I, Z1 and Z2 in this equation, we can obtain I double dash as 10.10 angle 129.09 ampere, which is exactly equal to I dash, which we got in previous case. As I dash is equal to I double dash, we can say that the circuit is satisfying reciprocity theorem in this circuit.